Hello students and friends, welcome to my YouTube channels. Today our topic is impact of the elastic body or collision of the two bodies. Collision of the two bodies. So based on these problems I will going to explain. So what they given here? A car weight of 5 kilonewton moving in east directions towards east. East I given here north, south, east, west towards east direction. Our velocity is given 54 kilometer per hour, kmph kilometer per hour. Collide with the second car. Another car will be there. Car number 1. This is car 2. Collide with the second car. What is the weight of the second car? 12 kilonewton. Moving west directions. So we see this directions. We are assuming here this plus and this also plus, positive. So this during the west direction, that means this velocity will be negative, they given here. That only you have to careful. What is the directions of the two car, those which are going to collide. If the velocity is perfectly plastic, two conditions will be there. What is meaning of plastic and elastic body? Suppose two ball will be there. These two ball mass m1 and m2. Before collision, velocity v1, v2. During the collision, they will collide at the small interval of times, and it will go the after collision. After collision, velocity will be v2 dash minus v1 dash. So with diagram I will explain here. Two ball is there or two car will be there, two body will be there, whatever. So this is m1 v1, m2 v2 before collision. This is called before collision. During collisions, what will happen? During collisions, see this, for a small interval of times they will come close. See this, come close. See, small interval of times. Again it will separate. So this both will go in the different directions. So this will go v2 dash, this is called v1 dash. So v1 is before collision velocity for block 1, v2 is before collisions block 2, after collisions v1 dash for block 1 and block 2 v2 dash. So how to solve this? We have two equations, laws of conservation of momentum. So first equations will find out laws of conservation of momentum. So what is there? Before collisions, what is the before collisions? m1 v1 plus m2 v2. After collisions, what is? m1 v1 dash plus m2 v2 dash. Now we have to see the velocity directions. Here velocity direction plus, here velocity directions minus, and he given here weight here. So we know the weight is equal to m into g. So mass is equal to nothing but w by g. So we will write here w1 by g, v1 minus will write. Then again w2 g by v2. Why negative I am writing here? Negative writing because the velocity is going towards west. So w2 g into v2. So directions towards west negative, towards east positive. Now m1 w1 by g v1 dash plus m2 no w2 by g v2 dash. We wrote laws of conservation of momentum. So now look here. What is the given here? Body is given plastic. Plastic body means, suppose this is rubber ball. Once they are colliding, it is regaining its original position. So this is called elastic body. Suppose you will tell some soil, mud soil, and just to make this two ball and collide, it will immersions will be there. But once you will remove this two block, they will not regain its original position. That means they will change the shape and size, is known as plastic body. If they will regain its original position, is known as elastic body. So here coefficient of restitutions will be there. This formula will be coefficient of restitution. This formula will be velocity of the separation, relative velocity of separation divide by relative velocity of approach, divide by relative velocity by divide by relative velocity of approach. Velocity of approach. So this is known as coefficient of restitution. So these symbols we are using E. What is the velocity of separation? See here, velocity of separation, what is? Relative velocity. That means V2 dash minus V1 dash. Relative velocity of separation. Relative velocity approach, V1 minus V2. V1 minus V2. If they given plastic, that means E will be 0. For plastic, E will be 0. If they will give elastic, perfectly elastic, E will be 1. So here what we can write here? 0 is equal to V2 dash minus V1 dash by V1 minus V2. So denominators will get 0. So what finally we will get? V2 dash minus V1 dash equal to 0. That implies we can get V2 dash equal to V1 dash. Take some another velocity Vc. We will take some another velocity Vc. So this, keep it here. Now, another equations, what is there? Law of conservation of momentum. Here we will substitute the value. Here we will substitute the value. So these things I am going to rub it. Now here we will substitute the value. Now look here. Substitute the value. What will be the W1? What is there? 5 by G. 5 by G. What is V1? Into 54. Into 54. Into 54 minus 12 by G into 72 equal to Vc. If you write here V1, V2 dash equal to Vc, take common. So what will be the W1? 5 by G plus 12 by G. We can write this. Now if you will solve this, 5 into 54G, then this will solve now. It is coming, already we calculated, it is coming 594G. It is coming minus 594 by G is equal to Vc, 12 plus 5, 17 by G. 17 by G. So here Vc you will get, G will get cancelled, 17 it will get 34.94. It is getting 34.94, I think, so we will check it. So 34 minus 34.98 meter per second. So now see your negative signs, what indicates? Second cars will move towards the west. So you can write V is equal to 34.98 meter per second towards west direction. Towards west. So this way we can solve this question. See, conditions 1, equation 1, this you give this equations 1, this you give equations 2, coefficient of restitution. Based on this we can substitute the value, we can get the velocity of the car. Okay, students, thank you.